Hello, students. Welcome back to your computer science class. So now we're going to start with cloud computing. In cloud computing, we know it is a trend in which you can store information on the cloud. It is a field of information technology where computer-based services are delivered over the internet, and this service can be accessible from anywhere to any to you to the user anywhere using any device. You just need internet. So these are the 10 features of cloud computing: resource pooling, on demand self-service, easy maintenance, large network access, availability, automatic system, economical, security, pay as you go, and measured services. The service that we get on clouds will include hardware, software, databases, storage, etc. This is the cloud architecture. There is a cloud which is connected to a server, which is connected to a router, which is giving you all the services. And on the front end, we have the user. The resources which are provided by companies called cloud service providers they usually charge a pay per use basis. Though through cloud computing, a user can run a bigger application or process a large amount of data without having the required storage or processing power on their personal computer, as long as they are connected to internet. So Google Drive or Dropbox or iCloud, if you're using any of these are all cloud services. Besides other numerous features, cloud computing also offers cost-effective, on-demand resource. A user can avail need-based resources from the cloud at a very reasonable cost. So cloud services are of three types: IaaS, PaaS, and SaaS. IaaS is infrastructure as a service. PaaS is platform as a service, and SaaS is software as a service. In SaaS, the users are possibly me and you. We are the end users who use it. And normally the services that fall in SaaS, that is software as a service, is basically packaged software or an application server or storage network. In platform as a service is normally used by application developers, and they get access to operating system and application stack server storage network. Infrastructure as a service is normally used by an infrastructure or a network architect, and they normally utilize a server storage network. These are the three models, and they categorize different computing services which are delivered through cloud. Infrastructure services, that is IaaS. These are the examples of IaaS: Windows Azure, Amazon Web Services, IBM Cloud. All of them provide an infrastructure that we can use. It's not for us, it's for network architects. In PaaS, that is platform as a service, examples will include, again, we have Windows Azure, AT&T, Rockspace, Force.com. These people normally provide a platform on which we can deploy a software, we can use the software. SaaS is basically a service. Service can be any sort of a service we get from Google App, from Office 365, Zoho, Ariba. All of them provide a service to us. The service, these are all examples given to us. So in software as a service, we have Gmail, we have Google Docs, NetSuite. All these which are used by the end customers through a cloud is called fall under SaaS. PaaS is basically used by developers, and they provide you a platform on which you can test your software, deploy your software, install your software. And finally, IaaS is infrastructure as a service, and it's normally used by system administrators. Grid computing. Grid computing is a network of geographically dispersed and heterogeneous computational resources, people in different parts of the world. It is more application specific, and it creates a sense of virtual supercomputer with an enormous superpower. It just creates that sense, but actually everyone is at a different place. The constituent resources are called nodes. These different nodes, they temporarily come together to solve a single large task and reach a common goal. So they actually work in a grid. They are actually not located centrally together in one place. They're all located at different places, but they're all coming together to do one work. Grid computing system requires at least one computer, which is a server, which can handle all the administrative duties. It requires a network of computers that runs the special grid computing network software that comes. And finally, it needs a collection of computer software called middleware. Where does grid computing is used? It's used in government offices, in telecom communications, multinational companies, financial organizations, etc. There are many types of grid computing. There is data grid, there is CPU or processor grid. Data grid is used to manage large and distributed data, which has multi-user access. CPU or processor grid is where the processing is moved from one PC to another, because a large task can be divided into subtasks. And again, this subtask is given to different nodes for parallel processing. So they're all processing together at the same time. In case of IaaS, that is infrastructure as a service, service provider who rents the required infrastructure to the user. Whereas in grid computing, multiple nodes join together to solve a common computational problem. This is the difference. The most famous right now, blockchain technology. It is a system that will allow groups of computers, which are connected computers, to maintain a single ledger, and this ledger is updated every time a new computer is added in the chain. This is an infographic that shows how a blockchain works. So a transaction is first requested, then a block that represents that transaction is created, then that block, whichever they have created, has to be sent to each and every block of the blockchain technology. Then the nodes are validated and the transaction takes place. Finally, the nodes will receive a receipt. They will receive a receipt or a reward of proof that the transaction is successful, and the block will be added to each and every block of that blockchain. And finally, the transaction is completed. If it's a decentralized ledger, then people will not know what's happening. Someone will request a transaction. The request is broadcasted to each and every node in the network. This request is even verified by all the nodes, and then the block is added to the existing chain of blockchains, and that is when the transaction is considered as complete. These are the most popular applications of blockchain technology. Most famous today is Bitcoin. It is based on distributed ledger, rather specific kind of distributed ledger called blockchain. Bitcoin is the first place where this blockchain technology has been used, but now it is being spread across globally because it lets you keep thousands of strangers honest and consistent. Blockchain is considered as a digital tracker because basically it's like, for example, if I want to take loan from the bank, This request is not only sent to my bank, but all the banks in the areas. Once all the banks in the areas will verify it and add it to their books or their account books, and only if this entry is reflecting in each and every bank, only and only then will my bank give me that money and the transaction is done. That means backup is in each and every place. And any mismatch means it's wrong, it's not validated. So it makes it easy to spot fraud behavior, making the transactions in through blockchain more secure. It allows digital transformation information to be distributed but not copied. Blockchain technology created the backbone of a new type of internet, and it has become the latest buzzword in the digital space. Of course, if you are working on this computers on internet, especially, cybersecurity is very important. It is protection of our systems, internet systems, including our hardware, our software, our data. And one of the most problems of the cybersecurity is the evolving nature of the risk. That means uh, the virus that the computer viruses, they change by the day, they modify themselves. Uh, so you are never sure what attacks can happen. It could be anything. So ensuring cybersecurity requires the coordination of efforts through an information system, and it includes all these. It includes making sure that there is application security, information security, network security, disaster recovery, business continuity, operational security, and end user education. This is another technology that is coming up. Uh, I'm sure you all must have seen quite a lot on it. We're all waiting for it. Hopefully, it should be here, I think, within the next 5 to 6 years. An autonomous car, that is a car that will drive on its own. It will navigate without human input. It will combine different techniques like laser, GPS, odometry, computer vision, and it will be able to navigate through our traffics. That would be great. Advanced control systems interpret sensory information to identify appropriate navigation paths as well as obstacles and relevant signages and all the relevant signs. This was interpretation, that means very close to wearable technology, and I had told you all to find out about this technology. So with this, we end today's class. We end the revision chapter. This is the final class before your unit test examinations. Unit test examinations are very important. Please study thoroughly. Don't get scared. Answer with honesty, answer in point form. Be prepared. Stay home, stay safe, take care, and keep learning. Thank you.